Welcome to Lakshmi Chemistry channel. Today our topic is inductive effect in organic compound. If a polar group is attached to the carbon in the chain, polarity is developed to the bond and it induces polarity in the surrounding bonds in the same direction is known as inductive effect. Or also you can say that the transfer of electrons through sigma bond is known as inductive effect. This effect is a permanent effect, permanent effect in the molecules as the distance of the polar group from center of the reacting carbon increases in the chain, its effect gradually decreases and almost ends at the fourth carbon. That means this effect may not be observed in open chain compounds containing more than 4 carbons. For example, 1, 2, 3, 4 and Cl group is there. Chlorine is attached to the carbon atom. Due to the high electronegativity of chlorine, it attracts the bond pair of electrons. Bond pair electrons. Hence, the electron density on 1, 2, 3, 4. Electron density on first carbon is decreases. Here the chlorine attracts electrons, it will get positive, partial negative charge. Then the electron density decreases, the first carbon having partial positive charge. That way, it attacks the electron, sigma electrons in C1 and C2 bond. Therefore, the polarity develops to C1 and C2 bond, the electron density and at C2 carbon decreases. C2 carbon decreases. Same way, C3 carbon electron density also decreases. Here is the partial positive charge. C4 carbon is far away from the carbon, therefore that this effect will not be observed on C4 carbon. In this example, chlorine is attracting electrons from the carbon chain. Chlorine attracting electrons from the carbon chain. This it is known as electron withdrawing inductive effect. Electron electron withdrawing inductive effect, and also this is shown as minus I it is shown as minus I. For example, NO2, for example NO2, NO2, fluorine, COOH and Cl, Br, OH is there. The order of groups exhibiting minus I effect is NO2 is greater than fluorine is greater than COH group is greater than Cl is greater than Br is greater than OH is greater than alkyl groups or C. Alkyl groups means any alkyl groups. Next, if instead of chlorine, instead of chlorine, for example, if electron releasing groups or electron donating groups attached to the C1 carbon. For example, For example, one CH3 group is there. One electron releasing groups or alkyl groups are attached to C1 carbon. It gives electrons to the carbon. It gives electrons to the carbon. Then here it will get partial positive charge and this carbon is get partial negative charge. Then the electron density on C1 carbon increases. This C1 carbon donates electrons to C2 carbon. Again the partial negative charge. That means the polarization is possible. Here the polarization is possible. This type of inductive effect is called electron donating inductive effect or electron releasing inductive effect or electron donating inductive effect. It is shown as plus I effect. Plus I effect. For example, tertiary, secondary, primary, and methyl groups are there. Tertiary carbons are more effective, plus I effective groups than secondary, and then primary and methyl groups and methyl group. Here we are discussing about inductive effect. What is inductive effect? Means the transfer of electrons through sigma bond is known as inductive effect. Two types of inductive effect. One is minus I effect, means electron withdrawing inductive effect. Second one is plus I effect, means electron donating inductive effect. Now applications. For example, we are telling amines basicity. Amines basicity. The basicity of amines can be shown by this equation. For example, RNH2 HOH or NH3 plus plus OH minus. Proton proton acceptors are called bases. Proton acceptors are bases. Proton acceptors. Proton acceptors are bases. Amines are bases because they are proton acceptors. In amines, here nitrogen atom is having electron lone pair of electrons. These lone pair of electrons donates to other electron deficient substances and hence it acts as basis. The basicity of amines is depending on electron density on nitrogen atom. The basicity of amines is depending on the electron density on this nitrogen atom. If increasing or more the electron density on nitrogen atom, higher will be the basicity. In general, you know that plus I groups are increase the electron density on nitrogen atom, which in terms increase the basicity. In minus I groups, if you take minus I groups decrease the electron density on nitrogen atom. Minus I groups decrease the electron density on nitrogen atom. Hence, it decrease the basicity. Decrease the basicity of the amines by involving the inductive effect, the relative basicities of amines. For example, I am writing one example here. For example, NH2, CH2, Cl, NH3, and CH3, NH2. Then CH3 taken to NH. CH3 taken to NH. In this example, chlorine is a, in this example, you can write the increasing order of basicity because we are trying to write increasing order of basicities. For example, in first one, here chlorine is present. Chlorine is a minus I group. Chlorine is minus I group. Minus I groups decrease the electron density on CH2 carbon, which in terms to decrease the electron density on nitrogen. Minus I groups decreases the basicity of the compound. That's why this compound is having less basicity, less basic compound. In then ammonia. Here you can observe this CH3, NH2 and dimethylamine. In these two are here one CH3 and this CH3. These two groups are plus I groups. Plus I groups increase the electron density on nitrogen atom. Higher number of alkyl groups, 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 greater will be the electron releasing effect. Hence, greater will be the electron releasing effect, and hence it is more basic compound. In this example, methylamine is more basic than ammonia. Dimethylamine is more basic than methylamine. Here, why? Because here number of alkyl groups increases. And next, acidity of carboxylic acids. Acidity. Acidity of carboxylic acid. I already know that carboxylic acids means the functional group COOH is the functional group of carboxylic acids. Carboxylic acids, for example, I can write or COOH plus H2O equilibrium here, or COO minus plus H3O plus. Carboxylic acids are proton donors. Proton donor. Proton donors are acids. Proton donors are acids. Carboxylic acids also proton donors. That's why they are also acids. The strength of carboxylic acids depends on the ease of dissociation of O bondage. Ease of dissociation of O bondage. The higher the bond dissociation of O bondage, greater will be the acidity. Inductive effect influence the strength of carboxylic acids. For example, plus I groups. For example, plus I groups are electron releasing groups. Plus I groups decreases the acidity by increasing the electron density on oxygen or density on OH oxygen, which in terms decreases the OH bond dissociation. So acidity decreases. When plus I groups are increased, the acidity of the carboxylic acids are decreased. If minus I groups are present, for example, where minus I groups are present, minus I groups increases the acidity of carboxylic acids by decreasing the electron density on OH oxygen atom, and thereby OH bond dissociation increases, so the acidity increases by releasing more number of protons. For example, HCOOH, HCOOH, CH3COOH, and ClCH2 COOH is there. In which compound is having higher acidic nature, which one is less acidic? In first example, there is no plus I groups and minus I groups. Here one CH3 group is there. CH3 means plus I group. CH3 means plus I group, electron releasing groups. Already you know that electron releasing groups increases the acidity of carboxylic acid. Plus I groups, plus I groups increases the electron density and OH bond oxygen, and the bond dissociation decreases. That means the acidic nature is less acidic than formic acid. Formic acid is more acidic than acetic acid. Here one chlorine group is present, Cl. Cl is a minus I group, electron withdrawing group. Electron withdrawing groups or minus I groups increases the acidity. Minus I groups increases the acidity. Total, you can write the more acidic, more as for example, less acidic compound is CH3COOH, then formic acid, then chloroacetic acid. Chloroacetic acid. This is the acidity of the carboxylic acids. Next one, stability of carbonium ion. Stability. Stability of carbonium ion. Carbonium ion means carbon having positive charge, or positively charged carbon species are called carbonium ions or carbocation. The stability of carbonium ion. Carbon having positive charge. Positive means here electron deficient compound. Electron deficient compound. Electron deficient compound or electron less compound. Here plus I groups or plus I groups increases. Plus I groups are electron donating groups. Electron donating groups increase the stability of carbonium ion, and minus I groups decrease the stability of carbonium ion. For example, CH3 plus CH3 taken 3 plus CH3 taken 2 CH plus next CH3 CH2 plus. This one is primary, secondary, tertiary, and methyl carbocation. In this one, tertiary carbocation is the more stable than secondary carbocation, then primary carbocation, and CH3. Why? Because here in tertiary carbocation, three alkyl groups are there. In secondary carbocation, two alkyl groups are there. Primary carbocation, only one alkyl group is there. Methyl carbocation, there is no any electron releasing groups. Electron releasing groups increases the stability of carbonium ion. If increasing number of electron releasing groups, the stability also increases. These are the applications of inductive effect. You know, in inductive effect, two types of groups are there. One is inductive effect, one is plus I groups, and second one is minus I group. Next to acidity, basicity, and stability. Already we are discussing about the plus I groups are electron releasing groups, minus I groups are electron donating groups. Plus I groups Plus I groups decreases the acidity of carboxylic acids. Minus I groups increases the acidity of carboxylic acids. Plus I groups increases the basicity of amines. Minus I groups decreases the basicity of amines. Plus I groups increases the stability of carbonium ion. Minus I groups decreases the stability of carbonium ion. This is the final conclusion of. You can watch this. We can explain all inductive effect. Thank you.